Alright guys, welcome to episode 6 of the Carbide 3D Office Hours series. Today we're going to do something pretty simple, but it's a technique that I feel like most people should know or should master because it unlocks a lot of really useful projects you can do in the future. So, how is everyone doing on this lovely spring day? It's about to hit 95 degrees here in Los Angeles. So for me, this is dreadful, dreary, but we'll get through. I had to turn off the fan just because that would interfere with the microphone stuff. So I'm going to be roasting in here. How's everyone else doing? Doing good. I'm seeing some affirmative responses, so glad to hear that. Basics of two-sided machining. The biggest thing to keep in mind when you're doing a two-sided part is how are you going to locate that part once you flip it over. Because if you're referencing off a corner and that corner moves, then when you flip the part over, if you can't figure out where you're going to start cutting from, the two tool paths aren't going to line up. So I'm just going to show you guys a couple simple tricks that I sometimes do when it comes to two-sided machining. And yeah, we'll take it there, and you guys can ask any questions as we go. I've got a couple questions from the community to answer at the end, and if you have anything else to add, just throw it in the comments, preferably towards the end-ish, so I don't miss it or forget it, or it just scrolls up and I lose it forever. So, without further ado, let's go. The part that I'm going to be doing today is this really simple, sort of like cliche, like this is the trivet that everyone sees when they like Google wooden trivet. So it's basically like you can make this on a router table or anything, but it's basically just a two 90-degree offset lines routed through a piece of wood. And I figured this would be an easy enough example just because I didn't want to come up with something too complex. This is really easy to implement in Carbide Create, but the techniques that I show can totally be scaled up to Meshcam or Fusion or basically anything else. Let's see. Yeah, machining a circle, it's very difficult to index that and clock that just right. So if you can do this with square geometry or something with corners, that would probably be the best. Or we'll talk later about some of the other techniques that might work in that case. So before we talk about flipping anything, let's make our our trivet model. I'm going to start with, this is scaled down by the way, just because I'm trying not to waste a ton of wood. I'm going to start with what size is my canvas? 4.5 inches by 3.5 inches, and my grid spacing is 1/4 inch. Stock thickness is going to be 0.3 inches. It can be anything. This is just for my example. I had stock that was roughly 5/16 of an inch thick. So that's what I'm going to do. And then I'm going to move the toolpath 0 to the center, just to make it a little easier to track everything. So I'm going to start with a rectangle, turning it into a square. I think that looks like a square. Let's check. 3.5 by 3.5. So this would actually make an okay coaster. And then I'm going to, just to make it look a little fancier, put a chamfer on the corners. Radius / width of about 1/4 inch. That looks fine to me. Unselect that, and I'm just going to make another rectangle just as a guide. You don't really need this, but this just helps me figure out where I want to keep my the lines going through my trivet. So apply that, and then I'm just going to start drawing diagonal lines. It's not really a super quick way to do this, so I'm just going to put in a couple, just doing a lot of clicking. If there was a way to do this faster, I would love it. But this works just fine. So once I have all of these in place, I can start thinking about how I'm going to index this part when I flip it over. So right now I know that my center is in the center of this trivet, but if I take this piece and I flip it over, I lose any sort of visual reference as to where this thing is, and if I cut it out, well, rather, if I don't fully cut this out of the stock, you can't really pick it up off a corner. If you're cutting this out of an irregular shape, like say maybe like a cookie from a tree, you don't have any features that are easy to reference off of. So the first way that I'm going to show you guys is to use indexing pins, which you can place anywhere. I like them to be on the center line, either in the x-axis or the y-axis. And if you just machine a matching pair of holes in your wasteboard, it's really easy to line up the two different pieces, your stock and the where it's located on the wasteboard. So I'm going to make a pair of 1/4 inch holes just off to the side of my trivet, let's say 0.125 inches. I'll just Control-C, copy that, and we're basically ready for toolpathing. So toolpathing for this, I'm going to start to make so let me pull up the trivet again, these indents, with a 1/4 inch ball end mill. If you're making this out of a larger piece of stock or making a larger trivet, you might want to use like a cove bit or some other larger round ball nose type end mill. So I'm going to just select my lines, holding down Shift and trying not to click off of them. I could also click and drag, I just don't want to hit the square around them. Hit contour, we're going to select the 202 ball end mill. Depth per pass, that's probably fine. Stock speeds and feeds, I'm okay with that. I'm not trying to win a race here or produce these like super quickly. The max depth that I want isn't all the way through the coaster. We're going to go down to 0.2 inches, and then we want this to be right on the line, so no offset. So I'm going to call these the grooves, and that is one toolpath. The other toolpath you would need for this is a toolpath to cut around the perimeter of this, but we don't actually want to do that because if we separate our trivet from the rest of the stock where the indexing pins are, you're not going to be able to reference them. So I'm going to do the cutout after I flip this part over. So the next most important toolpath for me here is the contour or pocketing toolpath for these pinholes. So I'm going to select them, go to contour. I'm going to use a smaller end mill this time. I'm not going to try to use a 1/4 inch end mill to make a 1/4 inch hole. So end mill 102, select that. In reality, what I would probably use is an 1/8 inch downcutting end mill. There's an Amano one in our store that I'd like to use, but any 1/8 inch end mill programmed in Carbide Create will basically do the same thing. So for this toolpath, you can, I'm just going to hit OK on all these default settings. Max depth all the way through, so use stock bottom. If I go on the inside and this is just a contour, we just get a simple toolpath like this. If this hole were any larger in diameter, you would have a little core left in the center. So if you want, you can optionally choose a slightly smaller step over, let's say 0.05 inches. And then if you do a pocketing toolpath, it'll actually just plunge in the middle a little bit, clear a little room, and then start going around. And that'll also actually help make it easier for that contour toolpath around the inside of the circle, and just help give you slightly better dimensional accuracy. So we're going to call these the pin hole pocketing, 2 T's, 1 T, whatever. And that's a really quick toolpath. And then once we're all flipped over, we're going to need a toolpath to basically cut the same grooves and then cut around the perimeter of our part. So that's going to be, again, 1/8 inch end mill, 2 stock bottom, and then on the outside of the toolpath. And I'll call that the trivet cutout. So these 3 toolpaths are basically everything we need to do. When we flip this part over, just with the way that this trivet is designed, the grooves that we cut on the first side are going to be reversed, and we actually want that. So I can use basically the exact same toolpath, just picking and choosing which ones I want to run for the first and second set. So for operation number 1, I'm going to want to cut the grooves for sure. I'm also going to want to make my pinholes for locating this part, and then I will just disable the cutout. So I would export this as like toolpath set 1, and then once I flipped it over, I don't need to make the pinholes anymore. They already exist, so I'll disable that, re-enable the cutout, and then machine the grooves, and then machine the cutout. So that would be set number 2. And so that's how I would machine this using indexing pins, which is really useful for irregular sized stock. Now, another variation of this would be to machine a recessed pocket to receive whatever shape you're cutting. So if you're cutting like an oval shape or anything irregular without straight sides, it's basically sort of like a poor man's soft jaws. So you cut a matching recessed feature that will perfectly contain this object and locate it. And so let me show you how I would do that. It's actually basically the same thing, but there's a couple things we need to do differently. If you're going to machine a pocket to receive this trivet, you need to take into account these sharp corners, which you can't machine sharp corners on a CNC with a round tool. So you need to oversize that pocket. And the easiest way to do that, while keeping just the overall bounding dimensions the same, just make the same square and don't use any chamfer or fillet in the corner. Or if you do, make it a much smaller radius. So when we machine inside this square, it'll have the same matching dimensions as our trivet, but the end mill will be able to go all the way out to the corners, and you won't have any conflicts in that radius. So I would use a 102 end mill. We could probably go with a higher step over. I usually machine these pockets pretty shallow because you just need enough to capture the part. So for something like this, I would go super aggressive, perhaps a step over of 0.1 inches. The depth of this pocket doesn't need to be all that great. Maybe just like a 1/16 of an inch, 1.5 millimeters ish, and then pocket toolpath. And then this will be the let's pocket maker. So this toolpath would create the recess that we could drop the trivet in after we flipped it over. And then the third way we could do this is because we're working with a square, it's really easy to just flip this part over, make sure it's aligned with the X and Y axes, and then just throw a touch probe on the back. And that'll help you pick up the corners. So if we do something like that, basically we don't need to do anything. So for both the pocket locating method and the touch probe, we would machine the grooves. Let me hide the pocket toolpath. We would machine the grooves, machine the cutout, flip it over, and then just machine the grooves. So those are our 2 sets of toolpaths. So let me pull up some video footage of what this would look like. I'm basically just using you guys to beta test my video. So yeah. So I'm starting with a piece of maple that is just obscenely large and super not flat. It's just rough sawn, so I'm just facing all of this down using the gator tooth clamps and the angle tool downs. I don't have a facing toolpath, I'm just manually jogging the machine. Super lazy, I know, but it works, and I don't need to worry about sizing the boundaries of the toolpath so I don't crash into the clamps. And then once I have all this done, I flip it over, put some double-sided tape underneath where the trivets will be. I have some clamps here also because the stock is actually starting to cup. As soon as you remove any material from wood, it's going to start to bend, and there wasn't enough double-sided tape in the world to keep this thing perfectly flat. So what you saw here is a mistake. When you're in Carbide Create, you need to be super vigilant about where you set your stock origin. Sometimes it's on top, sometimes I personally like to put it on the bottom, and here there was a mismatch between what I thought I had set my origin to and where I actually zeroed on my machine. So the very first groove that I cut ended up punching through the entire piece of maple. So anyway, this is what it should look like. Couple step downs, I think it's 5 passes per groove. And then once these are all machined out, you would switch tools, and then we'd switch to an 1/8 inch end mill. Here I'm machining the pinholes for indexing. And then for this particular example with pinholes, I'm not doing the cutout. The cutout comes second. So after this, I'm machining just a piece of scrap MDF, 2 holes, using the exact same pattern. So actually I need to pause here. In our toolpaths, we have all different sets of, we said set 1 of our toolpaths was to machine the grooves and machine the pinholes. We need to export a 3rd set of toolpaths, which is just the pinholes, so that that can be machined into the MDF, which is what's going on now. So once I machine those, I can try and insert 1/4 inch dowel pins in there. And sometimes they might be a little tight, so I like to just chase them with a drill bit. This could be from just backlash or just tool deflection. The most accurate holes you can get are drilled or reamed, and you can't really do that on a CNC router. But once the holes are there, even if they're just like 0.24 inches in diameter, drill bit's going to remain centered pretty well, so your accuracy is going to be really good even if you have to open it up just a tiny bit. So here, I'm machining the grooves on the opposite side, and then doing the cutout. I've got some double-sided tape underneath this trivet right now, but I have some extra clamps around the edges just to keep the stock from flying off since those weren't secured. And then once you have this done, you can pull it off. There's going to be quite a bit of sanding you have to do, but a little sandpaper, a couple files, it's not all that bad. So this is example number 2, and I basically just ran the exact same toolpaths minus the indexing pins with the cutout. So in a couple seconds, you'll see the cutout toolpath taking place, and that should leave me with a pretty square mini trivet. In my little MDF fixture, I'm just machining a really shallow pocket. This is actually shallower than what I modeled, so it doesn't capture the piece as snugly as it could. There's a tiny bit of play in there, but just having any lateral feature at all is going to take away any lateral forces. So if I'm just using double-sided tape, the pocket will actually keep the piece from shifting left and right a little bit, which is kind of nice. But since I know exactly where my toolpath is going to be, I can also throw some clamps on there if I wanted to. By the way, this is another goof that happened, I think on Wednesday. Basically, once I machined the pocket, I had my zero set at that level, and then the toolpath to machine the grooves had an origin set at the top of the piece. So my CNC thinks that the grooves should be machined basically all the way through the maple. So again, you get a spectacular failure that looks like this, and luckily I made a couple extra trivets. So now I'm holding down with clamps in the corners, and you can see where the grooves are intersecting. Personally, I think this is a really easy way to do double-sided machining. That's probably my preferred way, just because you know, even if you have an irregularly shaped piece, you can capture that super perfectly. So this is the third method, and it's just using a touch probe. You can stick it on the corner and pick up the edges, and it's pretty much as accurate as the other ones, but it does require just that extra act of probing, and it doesn't help you with repeat jobs. So if I were making a bunch of these, that pocket is never going to move. I can always slap down a fresh blank in the exact same spot. So for production work, that's probably your best bet. So I've got all this machined out, and that's what the finished piece looks like. I had to take a fine microfile and just take out some of the fuzz on the inside of those grooves. But for the most part, that's 3 different techniques that I like to use to index a part when you need to flip it over. So, if there are any questions about those specific techniques, let me know in the comments. I'm going to skip ahead a little bit and address a question I got on the forums, which is, let's see, how would I machine a 4-sided part? And that was in reference to a video I did a couple months ago where I did like a 4-sided Maltese Falcon or a Yoda Buddha or a graphite First Order Stormtrooper helmet. So I'll show you the setup I have in Fusion for that. You could do basically the same thing in Carbide Create. The biggest thing for any multi-sided machining is you have to know exactly how big your stock is. How wide it is, where the center point is. So like if you just slap a 2x4 on your CNC, it's not going to be super accurate because it's not super straight, the thickness isn't perfect. You really want stock that you know to be true. So either you have to mill it to a very specific thickness, run it through your jointer, your planer, and just make sure all the sides are perpendicular, or you just buy stock that you know is pretty square. Let's see. Let's say that for all of my filming, let me see, where's that? I am running a sweepy with no bristles, and that's just so that you can see the cut happening a little better. What I found is that with the vacuum attached, the vacuum suction is actually enough to neutralize the exhaust of the router, so you'll notice that there's sawdust and shavings right underneath here. Without the dust boot, those would be blown to every corner of my enclosure. But the vacuum suction is enough to neutralize the router, so basically however far the end mill flings some wood chips, that's where they land. If there's anything super lightweight that might get airborne, it gets captured by the dust boot. So for filming, I like running without bristles, and the stuff that lands on my CNC bed is easy enough to clean up and doesn't pose a health hazard to me. So that is that's why I'm not running brushes on Sweepy. So 4-sided machining. This is a much more complex take on things. That it might take a second to load. So this is a Stormtrooper helmet model that I got off Thingiverse, and I have when you're modeling everything, this is the model. I modeled in just a little cylinder as a stump because you need some way to hold this to your stock, because you can't really put tabs on it anywhere else. So I just put the Stormtrooper helmet on a stump, and in the manufacturing workspace, I've got 4 different setups. One, if you'll notice the orientation of the coordinate system for each setup is in a different direction. So from here, Z-axis is going to machine the part like this. Setup C is the opposite, and then B and D are intermediate on either side. And I picked the origin to be in the ZX center point at the very end of my stock. So I had a Carbide 3D vise on the left side holding a piece of square stock, and it was sticking out to the right of that vise. So this is basically what my CNC saw. And so for the first toolpath, I would do an adaptive clear, optionally do a parallel finishing, maybe a parallel finishing of just extra high resolution around the top of the head. And the way these work is each setup, you say, this is my stock volume. It's the same volume for every stock. It's just you're changing the direction. So I'm saying the z-axis here is just perpendicular to the, or parallel to the z-axis in the whole setup. My x-axis is arbitrarily this direction, and every setup has a different coordinate system like that. But again, this is just knowing where your origin is, where your stock is relative to it, and having tool paths that all work relative to those directions. So I could just take my square stock, flip it in the vise, run the next toolpath, and just basically proceed through it. So if you can generate the toolpaths for one side, you can generate the toolpaths for basically all the sides. It's just a little tedious because you have to replicate it a couple times. You should be able to use the same XY0 if you do both sides in one sitting. So with the origin that I had chosen, basically no matter how you rotated the stock, it would always be in the same spot. So I had to, when I was finding my 0, touch off on one of the faces and then subtract ½ an inch. So I know it's like if my tool is touching on the top side, the center point of that stock is actually ½ an inch down. And then if I touch off on the left and the right, I need to subtract the radius of the tool plus another ½ inch. So that is how I would tackle like a 4-sided job. Set your origin in the middle so it remains constant, or along another constant reference frame, so like maybe the back of the vise. Those are all typically, back of the vise is actually probably the safest. I think that's what most real machinists do. So that's 4-sided machining in a nutshell. I'll link to the video in the description of this video once it goes live. Another question was, do the stepper motors need any sort of maintenance on the Shapeoko? And the answer is not really. As long as you keep everything clean, what's more important is keeping the belts clean, keeping the V-wheels clean, because that will have a greater effect on the accuracy of your machine. So the stepper motor itself it really doesn't need any TLC, but making sure that the tops of your belts are clear of chips and that you don't get rolled into the idlers. That's always a benefit. I usually find the back of my CNC is where a lot of the chips collect that I miss when I'm vacuuming. And then just taking a toothbrush to your V-wheels and just cleaning them out every now and then is also a good maintenance procedure. Now specifically for the HDZ and the Z+, which use linear rails, those need to be, I mean, if you run them for months and months, they will eventually need to be re-greased. And so the procedure for that is, there's a couple ways you could do it. You could buy a grease fitting and stick them in the top and use a grease gun. Let me zoom in on these. There's a grease fitting in the top or the bottom that you can use. But a more low-tech way is to just make sure everything around this area is clean and remove the rubber chip guards, and then take either a syringe or just, I guess you could use probably not like a basting syringe, but just a plastic syringe that you can get from the like Amazon or any medical supply store. Doesn't need a needle. Just insert it, get a reasonable seal on the access port, and then just inject a bit of grease until you see it start to squeeze out around the bearings, and then just pop the rubber cap back on and just jog the machine up and down a couple times. You shouldn't need to do this unless you notice that your rails are dry. So if you just take a finger and you run them along the rails, if they're bone dry, that means you should probably throw some grease on there. But if there's a thin film of lubricant on there, you should be good to keep going. The indexing pins I used were just 1/4-inch dowel pins. I got mine from McMaster, which you could totally buy proper, like super precise indexing pins, but it's really not that necessary. Let's see. Actually, I think they're dowel pins. Yeah. So you can just get dowel pins of a specific diameter and of any length you want. But for the price you pay for these, you might as well go to the hardware store and just search for any raw rod stock. These come in steel, these come in aluminum. It's a couple bucks for several feet, and you can just chop these up into whatever lengths you want, use them for your own projects. That's personally what I would do if I didn't want to pay for shipping and get super precise high tolerance dowel pins. Even wooden dowels would work. It's really just about having something there that will align your stock with what's machined into your wasteboard. You could install Zerk fittings in there into the linear rails, but for the most part we think that's overkill just because we're not in a super high pressure or just degrading environment. Ground pins, off master, yeah, that's, if you want to do it properly, that would give you the best tolerances and alignment. But yeah, whatever pins you want to use is totally okay. So, this is actually a fairly short lesson, so if you guys don't have any more questions, or if you have any more questions, drop in the comments now. I want to just shout out the Carbide 3D Community Challenge. So we run these kind of seasonally, and right now, up until April 30th, if you enter the contest, you have a chance to win an HDZ and other mystery swag, including the shirt that I'm wearing. So if you like this design, you should submit something for the community challenges we run on the forum. Do I zero at the side of the indexing pin or the center? Side seems... So let me go back to Carbide Create. My origin for the indexing pin setup is in the center. And I just do that out of convenience, just because I can keep track of where everything is and there's some nice symmetry going on. When I machine the pins in my wasteboard, they have the same origin. So the center point between the two pins is still directly in between. So I can machine the first operation, get stock with grooves in it, 2 holes in it, pull it off, 0 at my wasteboard, machine the 2 holes, slap down my stock, find my new 0 point on top of my stock, and then just machine. Like I don't need to jog left, jog right. It's just wherever I set my 0 to machine the indexing pins, I just keep the 0 right there. There's no need to do any sort of offsetting or anything. Which reminds me, if you do use the touch probe, keep in mind that, where is it? If you're using a touch probe, that's going to find, wait for it, that's going to find you the origin over the corner of your piece. So because my 0 point was in the middle of the trivet, this 0 that the touch probe found was incorrect. But I know that my trivet is 3.5 inches in length and width, so once I find that corner, I jog in by 1.75 inches and jog up by 1.75 inches, and that is the 0. So just keep in mind that you need to either make sure that your origin that you find for your second operation is the same as what the touch probe's giving you, or you account for that and you jog to the correct origin using that corner as the reference. HDZ back in stock. I don't have an answer for that, unfortunately, just because our supply chain is so boogered up. And also, like, our staff in Illinois, they're sort of on a skeleton crew right now. Hopefully, sometime next month, but we can't really make any promises. Each time you have to 0 or probe a coordinate, the more likely you are to introduce error. That is totally true. And each time you use a touch probe, if you're using something like a single flute end mill, you need to make sure that the end mill is turned the correct way. Because if you imagine, I wonder if I can just draw a really simple, let's pretend that this is an end mill. So that's going to be the flute. So I'm just going to make a really quick visual aid here. And I'm actually going to move this right here. So if you pretend that this is the cross section of a single flute end mill, and that this outer square is our touch probe, you need to make sure that when you're probing, let me turn off snapping. When the end mill comes in, the outermost point is on like the radius of the cutter. So if your cutter's oriented like this and you come in on the touch probe, you're going to get a false reading. The 0 you find is going to be offset to the right because the way the flute is rotated, the end mill's coming in closer than it should in order to touch off on the touch probe. So you need to rotate the end mill just enough to make sure the outermost point is what touches the touch probe first. So something like this. For a 2 or a 3 flute cutter, it's a lot less likely that you'll fall in one of these valleys. But for a single flute, for sure, you gotta be aware of these things. And so the more you use like a touch probe for finding a 0, the more potential chances for error you have. So by machining that pocket to locate your pieces, it's a lot more foolproof. You find the 0 once, and everything is relative to that pocket. Nothing moves, you don't need to reprobe anything. The more you do, the more chances you have to screw up. And in the case of this project, I screwed up twice. So if you're doing production work, definitely try and make yourself like a custom fixture plate or some way to hold your piece repeatably so that you don't need to keep finding the 0. So it looks like I don't see anything else outstanding at the moment. So I will, class is dismissed. Thank you all for joining. I'll stick around in the comments or the live chat for a few more minutes after we conclude, just to answer any other lingering questions. But thank you all for tuning in, and I will try and post a question thread for episode 7 in the forums maybe Monday or Tuesday, just because I'm running out of ideas. I don't know what you guys want to learn. So if you guys have any suggestions or like things to machine or techniques that you want to know more about, drop them in the forum once I have that thread up. And yeah, until then, good luck, have fun, enter the contest in case you want an HTZ, and I'll see you again next week.